Welcome to a lecture series on digital image processing. In this lecture, we are now going to discuss about the post classification filtering. After doing classification, some of the pixels, one or two pixels, randomly distributed within the major classification has to be reclassified or regrouped or filtered out and then make a combine of the larger group. So it is a process, it is important for all the classification. So this is called post classification filtering. And in this filtering, only we will be able to reduce the number of misclassified pixels into various groups. Say for example, if you are classifying a vegetation, agriculture land, some of the pixels within the agriculture land, only one pixel or sometimes two pixels, which will be identified as other object like water bodies or the what is that fallow land, something like that. That has to be really grouped into agriculture land. So you have to select such a random, unclassified or misclassified zones or the object into the group, real group. So this is normally we do with we have a system called kernel 3 by 3 pixel value. So that will all the sides it will be 3 by 3 or 5 by 5. The center pixel will take the take the average of the whole pixels, and then that will convert into the that will be taken as the base, and then we'll look at the base of the classified image. If this is 63, then if the image is 20, then this 63 will be loaded into that particular pixel, and then that will be reclassified. It is called a 5 by 5 kernel system, which will move in the entire what is that entire pixel value, and then the misclassified or wrongly classified those small pixels, not it will not take sometimes 10 pixels together. Sometimes inside water body will be there. Now you know that what is that because of artificial recharge, people have constructed recharge pond in every agriculture land. So that it will not touch that bigger object. A smaller object it will do. We'll see how to do post classification filtering in digital image processing demonstration through the NV software. And now in the available bands, you are now opening the band 1. You see this is the band 1 data of unsupervised classification combined. This is the classification major, and this is the whole image. This is the image what you are looking at these portions. In this is the image scroll toolbar box display, and this is the selected band display, and even bigger you want, this is the portion of this. Now once if you are opening your unclassified images, now you are going to do the post classification. You see, you take the cursor and check the value. Sometimes inside 1 or 2 pixels, look at that, zoom it, move over the entire image, and feel that you see you have 1 pixel is odd man out. This type of small pixel has to come together with this object. This is the major object. You see, you have to move around the places and check one pixels, which definitely it will not be a separate group. It will be a group of the major one, which are nearby that. You know that this is okay. This is okay. It is bigger in class. Similarly, you move around the places and check use water body, no issues, but within the dense forest and degraded forest you have problem, and then those area you have to go to major, and you see you have to go to classification, post classification. You have to select majority and minority analysis. Majority and minority analysis. In this, once if you click, you will be able to get your classification input file. You have to select the unsupervised classification. Once if you select the file information, you check the file information is correct or not, and then give OK. And in this, you see select all what is that classification which you have done: water body, degraded forest, dense forest, agri area, and classify. You will be having 5 items which was selected. And now you see the kernel size. This is what I said. In the center pixel is the value of the dense forest, sometimes, or degraded forest. If you want to group it into degraded, dense, you can make it out. Normally we move with 3 by 3 or 5 by 5. Center pixel weight you are giving 1. This is very important. Center pixel value, it means the other pixel value it doesn't touch, it will move without any changes, or the and it will take the average of all pixels, and then in the center pixels it will change, and choose the output file name where you want to keep. You take your destination and then save the file output as a unsupervised combined filtered output, and give open, and here you have to give OK. Now your results are coming now, right? Display BAMP display, and this is the result. You see, this is the result, and you have to go to link the display. This is the result of your after kernel, which you move the 5 by 5, and then you see, you'll be able to see the changes here even. And majority of the unclassified small pixels are grouped into the major pixels. But anyway, we will link the unsupervised classification and the filtered post classification filtered data. And once if you link, it will be good. You see, dynamic overlay, you have to make it off. Now you move the cursor, wherever you move, it is always linked with all 6 windows. Look at this window and this window. You see, you have a small pixels. It is classified wrongly with respect to other groups. Is now being classified into the major group dense forest. It was classified in degraded forest. 1 or 2 pixels that has to be really taken into the main pictures. This is how the filtering operation is done. Once if you do the filtering operation, it means the quality of classification output image is increased, and you can use this for your further studies. And a lot of applications are there. This we have even checked in the field that after doing this post classification filter, enormous quantity of that unwanted, you see, this is 2-3 pixels are there, that's why it's not. You see, you look at that here and look at here, pixels of this, it is regrouped into the major dense forest, and this is really degraded for us. So this is how we do with the post classification filter in the NV platform. So with this, the lecture is come to an end. Thank you very much.